So hello, and today, as discussed, we'll be studying about lists. So let's go ahead and study about lists. So first of all, we'll go through what basically a list is. Okay. So consider list as a collection of different type of data. So you want to store many kind of things in a single container, then or a single variable, then you will be using list. List is basically a data type or data structure, the ultimate dynamic container. So what basically the list is, you can just understand with this uh, diagram. So first of all, is list is ordered and mutable. You can change list items by using indexing. Yes, so it's mutable. And heterogeneous data. That means it's different kind of data is stored here. First of all, this is a string, this is an integer, this is a float value. So different kind of values are stored in the list. Now, as you can see, this track or the conveyor belt is pretty long, so it's dynamic and resizable. So it can, just change its length as per our need. So it's dynamic in nature. So what is an example of a list? As I have already taught you this, so you can just write all of this like 1024, 3.1415, or hello world. All of these are a different type of items in a single container called a list. Now, how do we create a list? Now, creating a list has three, just creating a list has three methods. First of all, square brackets. You can just use normal square brackets like this and put the values inside of it. Then there is the list method. You just write list, and inside of that list, you write different type of data you want to store, just like this. And what is the third method? The third method is basically the multiplication operator. You just write the item in the list and times how many times you want to create it. Like if I write this times 7, it will create 7 storage values for 2. So it has created 7 storage values for 2, or sorry, 0, or 5 storage values for 2, as we have written here in this syntax. Now, list can contain data, but it's not basically referencing data. It's referencing to its memory address. So when you send letter to somebody, you don't just write their name, because names are very similar and you can get confused easily when you use names. But if you use address, address is unique. You will have your own address. Your friend will have your own address. Your teacher will have your own address. Your relatives will have their own address. In the same way, every item in the list has their own address. So addresses are shown in hexadecimal. So this is 0x10a, 0x10b, 0x10b is same because 2. So Python is pretty memory efficient language, so it stores same value in same memory addresses. Like there is 2, so it's storing it in the same address, so it can be accessed, and it also is efficient. There is 0x10c because it's a string, so it has a different address. So at it, as it's written here, Python list store references, not values. Okay, this is just an index of memory addresses. Modifying a mutable object inside a list changes original object, while reassigning an immutable object directs the pointer to a new object. Now it works same as navigation in the string. You just write a, then the indexing you want. The same way it works in the negative indexes, as you can see. So this is the positive index 0, 1, 2, 3, 4, and here it will start from -1, -2, -3, -4, and -5. Alright. Now next is mutation. So mutation means changing the value at a particular point. So just suppose that there is a value 20 already pointing to this memory address, but now you want to change this memory of 20 to 25. So you'll just write a of index, which is 1 to 25. So it will now just remove this 20. It won't point to this address, rather the value 25 will be pointing. As written below here, because lists are mutable, we update elements not replacing by physical data but by accessing the indexing and redirecting its pointer to a completely new value. So before, this memory address was pointing towards 20, but now as we have changed this to 25, now it's pointing towards the value 25. So this is how we change the value, or just mute the value. Now the expansion matrix. Now how do we expand or just add new elements into the list? So there is a function called append, extend, and insert. So what is the function of all these three? I'll just tell you. So first of all, append. Append, as the English word append means adding. Append means adding. So it just adds a single value. So you have to remember these things, that append adds a single value. Insert inserts a value in place of some other value, and extend adds a different list. So consider this as one list and this is one list. So it's already adding multiple items into the list A. And slicing is not done in. So now the deletion decision index. Now this is few more function you have to learn here. Now if you want to remove a value, you just type remove, then the value a dot remove 2, then it will remove 2 from this. We'll just erase it from here. Now if you don't want the value back, you'll just remove it by remove function. If you want the value back, or you want it as an output, you will write a dot pop, and it will pop out the last value. Or then it, you want to delete it, then delete which element you want to delete, then clear. It will just clear entire list. It will just create an empty list. So these are the few functions you have to learn, because these are very important. Uh, we'll just use them in the VS Code after teaching everything. Now, iteration. How does iteration work in list? Same as the strings, but here this is treated as a single item. So this will be inside item every time you iterate. So it will print apple, banana, and cherry respectively. Now, this is just nesting of lists. So you are just putting list inside of a list. There's nothing else. If you list, if you nest a list inside of a list, then accessing it will be different. Then you'll have to use two index. Suppose you want to access this value 4. Okay, the rightmost value. So first of all, this is treated as one element, and this entirety is treated as different elements. Same with this and this. So you want to go to the second element, so we'll write 1. Now second element of that second element, then again 1. So it is accessing 4 now. If you want to access 2, then you will write a 0, because this is the first element as an entirety. Now then we want to access 2, so it's second element, so we'll write 1. So it's 2. So if you are seeing it properly, if you have studied math even a little bit, then you can see it's acting like a matrix. So this is 0 0 0 1 0 1 0 1 1. All right. So this is how it acts. It just behaves like a matrix. Now next is operations. So this is just like a summary for everything. Now, how do we create a list? These are three methods we learned just by using square brackets, list functions, then multiplication operator. How do we navigate? Using indexing and nested indexing. How do we iterate? Using a for loop, just like strings. It's similar to string. Then how do we update? First of all, we can just use the indexing to update. We can use append, insert, extend, remove, pop, delete, clear. So all of these will be just applying it in VS Code. So you just read this sentence by then that lists are not just storage, they are dynamic networks of memory references designed for high performance manipulation. So we would list because it's pretty efficient, dynamic, and pretty smart, you can say. And just revise all of it. This PPT, you can just understand list by this diagram itself. Just treat it as a railway track, just like you treated strings as keys of the keyboard. You can just treat it as railway track, or you can also treat it as keys, but the keys don't have multiple values or different values. It's just homogeneous collection of characters. That's why it's represented here as tracks or conveyor belts. So this is it for the theory part. We'll be implementing this. So what all we have to implement? We have to implement all these things we have present here. Yes. First of all, we'll be creating few lists, but you have already created them. But I'll just make you revise it. Visual Studio Code. We'll make a different file for this Python. Okay. So first we have to create a list. Okay. I'll just write it down for you. Creating. So I just created a list. Now I'll just create a list with heterogeneous data. I'll just create a list P with different types of data. As you can see, this is a string. This is what do we say? A decimal. This is a float value, and this is a Boolean value. Now what we have to do is create list by using the list creating list using list constructor. So we'll write C equals to list and then just write data inside of curly braces. Sorry, parenthesis. Now we'll also create list using multiplication operator. We'll create it using 5 times 7. Now we'll print all of them. Print all the lists. We'll just run it now. So as you can see, first of all it printed 1 2 3 4 5, row 1 2.5 true, then again 1 2 3 4 5, then 5 5 5 5 5 7 times. Now we'll just see, next thing we have to do is navigate. All right, navigating through the list. Now we are just navigating through the list. We'll just index it. Let print a of 0 and just print it. So this is how we navigate. We printed one error. We can also do the same with others. Now let's say negative indexing for B. I say -1. I just print it. So it gives true because the last element in B is true. Then we can do less nested. Let's make a nested list. Uh, Creating an embedded list. So I just type E, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3 is one list. So I can just make you visualize everything. So just think 1, 2, 3, 4, 5, 6, 7, 8. This is a matrix and this is what I have written here. So if you want to suppose access 5, what you will write? So this is indexing, so we will write 0 and 0. 1, 2, 0, 1, 2. So this is what? First row, first column. So you will have to write 1, 1. Alright, in order to print it. So we'll write print E1, 1. It should print 5. Yes, it's printing 5. So this is how lists work, and you can just navigate through the list. Sorry. Now let's just iterate through the list for I in A, print I. It's printing 1, 2, 3, 4, 5. Now this is how you navigate through normal lists. Now what if you want to start a for loop inside of a embedded list? To start it, you'll have to take two variables I and j in E. Print ij. I guess it should work. No, it won't work. Sorry, I didn't write it. Hmm. It won't work because it's just a single variable. So what we can do is we have to run a less nested loop for this. For j in I, print j. Now it will print 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll just print here that we are printing embedded list. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you don't want to print it like this, you can just do for I in E, print I. See, as I just said, it acts just like a metric. Now we'll just try few other things. We have tried all of these. Let's just try mutating through these commands. First of all, we'll update. So we'll just write updating the lists using indexing. So to update it using indexing, we just write a or 0 equals to minus of 123. Then we'll just print updated value of a. We'll print. So it printed what? Minus 123, 2, 3, 4, 5. Here now. Because the value of a is updated using the indexing. Now let's say I'll do a dot pop. It won't give anything. If I do print a dot pop, it will give 5. That means it has popped out the last value from the list. Now, uh, Hmm. Now we'll see next function or method. We'll say a dot remove 2 if the system is suggesting. It's not the system suggesting, by the way. It's an extension called GitHub Copilot. So this is updated value of a after removing 2. So it's minus 1, 2, 3, 3, 4, 5. It's not printing 5 for some reason. Have we popped out somewhere? Yeah, we popped it out, right? That's why it's not showing, because we popped it out. So we can just write print pop value from A. So then we can do insert a dot insert 1 to 100. So we are inserting 100 at index 1. That means 2 will be replaced by what? So 2 won't be replaced, 3 will be replaced as we have updated the value. Okay, so 2 is, yeah, so 2 will be updated as 100 now. If I do 2 here, then 3 will be updated. Oh, sorry, we are inserting, my bad. We are just inserting to it the value. We are inserting the value 100 at the index 2. So that's how it's working. We'll just do it as 1. So yeah, it didn't get saved. Yes. Now pop is done, remove is done, insert is done, append is done, and extend is left. So let's, okay, append is not done. So a dot append 200. Print the updated value of a after appending 200 is a. So we'll print it. So it's 200. Now last thing left is extend. Print, okay, a dot extend this. So what we are doing is just extending that list and updating another list. So this is how it works. So this is the code. You can just take a screenshot of it. Really important code in my opinion. This is how we create a list. Different how we create a list using different methods than how we are creating an embedded list, which just acts like a matrix. And you can use different type of data here. Either it's numeric data, it's floating point data, it's character, boolean, anything can be used here. I use numbers so that it's just gets into your mind. Now then it's indexing. How do we index it? Then we learned how do we iterate through a list. Then there are many things we did. We studied how does an update function work, how does an method of insert works, append, extend, remove. Suppose I write delete here now. Would it work? Yes. So these are a few methods I taught you today. So there are many questions that are to be done because if we start doing questions now, there will be lack of questions. So I'll just make different video lectures of 30 minutes each for list, strings, and upcoming lectures we'll be studying dictionaries, tuples, list comprehension. We have already studied, but we'll revise it again. Then after that, we'll do a few questions again. Then we'll be going through the object-oriented programming concepts. In that, there are four major pillars that we'll be learning: encapsulation, polymorphism, uh, inheritance, and there is one more, I'm forgetting it. So these are the four pillars. We can just search. So there are basically four pillars of, oops. So it's just inheritance, abstraction, polymorphism, and encapsulation. These are the four pillars that we'll be going through. And yeah, so after that, we'll be studying about classes, objects, and blueprinting. After that, we will also learn exception handling. What are exceptions? How do we handle them? And that will be it for our course. And there is a separate topic called what do we call it? We call it regex. Regex. That its full form is regular expressions. So regex is also pretty good topic. If you want to learn, you can learn it from Geek for Geeks. It has it explained everything. And all these topics that we are studying right now are also taken from Geek for Geeks. Let's just revise what we did, all of it today, and I'll just give you some important points. First of all the methods you have studied. Then few important thing, that list is mutable, it's ordered, and how it's different from string. String only contains as characters. It has characters, right? And I want to also teach you about one another thing that's called ASCII values. ASCII means American Standard for Standard Characters for Information Interchange. Now I'll just show the ASCII values to you. ASCII value chart. You can just, these are few ASCII values. So ASCII values are these, and these are the symbol that they represent. So A, B, C, D, E, F, G, from capital to small, everything has its ASCII value through which computer reads the characters. But right now, ASCII value has been replaced by, I don't remember the name right now. So it was like encryption method. Uh, I don't currently remember the name. I'll just tell you it in the next lecture if I remember it. So that is it for today's lecture. If you find anything that you are facing difficulties with, you can just get down in the comments, and I'll help you with the comment in the comment section. And so the next lecture will be on these topics. As you can see, here are few topics. Lists are done. Then we'll go with tuples, then dictionaries, and sets, and list comprehension. These are a few topics that we'll be going through in the coming videos. And after that, only a few topics will be left. So before doing those topics, we'll be doing few questions that will sharpen up your mind. So that is it for today, guys. We'll see you in the next lecture.